Hi everyone, my name is Noah, and today we're going to talk about composite bicycle frames. So to begin, let's talk about why bikes are important in the first place. Today, one of the main uses for cycling is commuting and other errands, particularly in urban areas. When cycling, a human uses only 35 calories per mile, while a car uses the equivalent of 1,860 calories per mile. This makes biking the most efficient form of transportation. Cycling is also a popular sport across the world with varying levels of competition from casual recreation to the Tour de France, one of the most prestigious cycling events held each year. The history of bikes dates back to the early 1800s when bikes were made of wood and didn't have any pedals. Modern bikes have typically been made of three materials: steel, aluminum, and carbon fiber. To start, steel bikes were made of varying thicknesses and dimensions of these steel tubes. And one construction method, which is also used in composite bikes, is called a lug. So you can see here the two tubes of the bike are joined using this other metal structure, which is referred to as a lug. One alternate method of bike construction on steel and aluminum bikes is welding, where the tubes are joined simply using a weld. And this eliminates the need for a lug and can reduce the frame weight a little bit. Ultimately, aluminum replaced steel as the material of choice for bike frames, mostly because it could reduce the weight of the frame. The only downside is that the yield strength and ultimate tensile strength of aluminum are very similar. And so as a result, these bikes are generally overbuilt, which can result in a stiffer ride, which can sometimes be undesirable. So these aluminum tubes are actually a lot thicker than similar steel tubes, but because of the low density of aluminum, they are still lighter in weight than comparable steel tubes. Today, carbon fiber reigns supreme as the bike frame material of choice for professional and most recreational riders. This is mostly due to the incredibly high stiffness to weight ratio of carbon fiber compared to both steel and aluminum. Unfortunately, we don't have any carbon fiber frames to look at, so let's shift gears and walk through how they're made. There are a few different manufacturing methods used for carbon fiber bikes. One, shown here, is a semi-monocoque design, in which the main triangle of the bike is produced as a single piece using pre-peg fabric. The second frame construction features lugs, as shown here. The main tubes of the frame are comprised of carbon fiber that then connect to each other using either aluminum or carbon fiber lugs. For a semi-monocoque frame, intensive finite element analysis is used to determine the layup schedule and the ply direction to best withstand the required load cases, while minimizing weight by not adding additional plies. As seen here, areas in blue experience less stress, so material can be removed and the frame weight can be reduced. Alternatively, areas in red are under higher stress and need additional layers. So now we will talk about how these frames are made. The main raw material are carbon fiber pre-preg fabric with epoxy resin. Most of the fabric is unidirectional, with some woven fabric used where the loads are not well known. These blue pieces are pre-cut pieces of pre-preg that are carefully laid into a mold to form the bike frame. In some cases, this molding is done in several steps when complex shapes are required. There are two main drawbacks of composite bike frames: cost and durability. The main triangle of the frame can require a few hundred individual pieces of fabric, which are laid up by hand in the mold. This is a very expensive process. On the durability side, carbon fiber is very brittle and can suffer catastrophic failures, as shown here. Additionally, since the frame is made up of several layers, cracks and damage to the internal layers can go unnoticed, resulting in a potentially dangerous riding situation. To combat this, bike companies are using CT scanners to be able to look underneath the outer layer of the frame after manufacturing and testing. It is critical that these frames are built as designed, and this technology allows for bike companies to do just that. Additionally, other fiber materials such as Integra and Dyneema are being used with the carbon to improve the properties of the frames. Integra is a polypropylene plastic fiber, while Dyneema is a polyethylene plastic fiber, both of which can improve the impact resistance of the frame when used with carbon. By improving the impact resistance, the frame will be less likely to fail in a catastrophic fashion, resulting in fewer injuries to riders. So that concludes our discussion of composite bicycle frames for today. Hopefully this information is useful to you next time you're riding or looking to buy a bike.